In this chapter, we will be looking at some preliminary concepts in trigonometry. In this lesson, we will be looking at solving second-degree trigonometric equations.
Now, just like in the previous lesson, we're gonna jump in and just start doing examples here pretty quickly. But just as a brief introduction here, what we're looking at now are trigonometric equations that are in second degree. Okay, so we're looking at squaring the trig functions here, which in essence takes these equations, and in the last lesson they were simple kind of linear, what you might call linear functions. Now they're going to be quadratic functions in trigonometry here. So as it says here, there are two types of second degree trigonometric equations, one in which the second degree term can be isolated, okay, and others in which it can't. Okay, so in the first type here, what we're going to do is we're going to isolate the square root both sides, and solve the resulting first degree equation here. Now, this is a pretty straightforward one, and we're going to see a few examples of that. You'll love it when that happens. In this case over here, what we're going to do is we're going to set the equation equal to 0, and then we're going to factor. And if you can't factor right off the top of your head there, if you're having troubles with this, remember you can always use the quadratic equation. Now, the quadratic equation doesn't solve the trig part of this. What it does is it solves the algebra, okay? Because there's going to be that layer of algebra that we got to bust through first. The quadratic equation can help you get through there. Then what you do is you solve the resulting first degree equations, okay? But that's the whole lesson. This is the whole point of what we're doing right now, is that the second degree equation requires factoring, or it requires some algebra work before you can get to the trigonometry.
Solve the following given the domains. Give exact values where possible, otherwise round to the nearest hundredth. Tangent of theta squared plus tangent of theta equals 0, where theta is between 0 and 2 pi.
So for this equation, just like we've done a bunch of times before, the first thing we're going to do is take a quick look at that domain. And this is telling me to solve this between 0 and 2 pi, so that's a good complete rotation in the positive direction. We're in radians, obviously. Now, I need to solve this. Now notice I've got a tan squared and a tan. What I'm going to do here is I'm going to replace the tangent of theta with x. And so what I'll do here is I'm going to solve the quadratic part of this first. Now, I can't isolate x right off the bat here, so what I got to do is I'm going to factor this. But it's a fairly simple one. It's just a common factor. So this will get me x times x plus 1 is equal to 0. Now, if that's true, then I've got one of two scenarios here. Either x is equal to 0, or x is equal to -1. Now, I've solved the quadratic part of this. So now I'm going to plug the tangent of theta back in. So either the tangent of theta is equal to 0, or the tangent of theta is equal to -1. Okay, now let's think about this. Now we've got two equations to solve. And this is now exactly what we've been doing the last couple of lessons here. When tangent is equal to theta, tangent is equal to 0, what I want to do here is I want to think about that unit circle, okay? And my points here, 1, 0. This is the point 0, 1, -1, 0, 0, -1 here. Now remember, tangent is the y coordinate over the x coordinate. So I got to think what pair there would equal 0. Well, it won't equal 0 when the x coordinate is 0, because then I get y over 0, and that's undefined. So this can only happen when the y coordinate is 0, and that occurs on the x-axis. So that's going to occur, keeping my domain in mind here, okay, 0 to 2 pi. This is going to occur at 0, at pi, and then it'll come around to 2 pi. And notice I am including both 0 and 2 pi, even though they are essentially the same angle. Okay, so 0 pi and 2 pi come from this factor when I factored that quadratic here. Now I look at tangent of theta equals -1. Well, tangent is going to be negative in quadrants 2 and 4. Okay, so I already know I'm going to get a second quadrant angle and a fourth quadrant angle out of that. Now I need my reference angle, so that's going to be the inverse tangent of +1. I don't need the negative in there. I just need to know how big the answer is, not where it is. I already know where it is. And what function here, or what reference angle connects tangent and 1? At this point, I'm hoping it's becoming more and more automatic for you that that's pi over 4, or 45 degrees. Pi over 4 tells me that what I'm doing is I'm chopping up the top and bottom halves of the circle into quarters. To get into the second quadrant, okay, that's this terminal arm right here. That's 1, 2, 3. pi over 4. And to get into the fourth quadrant, that's 1, 2, 3, 4, 5, 6, 7 pi over 4. And so these are my answers: 0 pi, 2 pi, 3 pi over 4, and 7 pi over 4.
4 times the sine of theta squared minus 1 equals 0, where theta is between 0 and 2 pi.
Okay, so here we go again. And actually, this is the same domain that we were just looking at there, 0 to 2 pi, so just one complete positive rotation. Now in this case, notice that I'm only seeing one representative of the trig function here. This is actually fairly easy to solve for. I don't need to replace the trig function here with a variable. I can basically just get it isolated. So, whoops, 4 sine squared is equal to 1. So sine squared of theta is equal to 1/4. And now I'll take the square root of both sides, but I got to remember something here. This introduces a plus or minus in my answer. Okay? And then the square root of 1 is 1, the square root of 4 is 2. So my answer is plus or minus 1/2. Now the significance of the plus or minus here is that sine is positive in 2 quadrants, and it's also negative in 2 quadrants. So what happens here is we are looking in all 4 quadrants. So to get my reference angle, it'll be the inverse sine of just positive 1/2. Okay, because I don't need to include signs in there. I'm just interested in the size of the answer, not where it's located at this point. And what reference angle connects 1/2 and sine? Well, the answer is pi over 6, which means we are chopping up the top half of the circle into sixths and the bottom half of the circle into sixths. Now, the terminal arms that we want are always the ones closest to the x-axis. So now we just count them out here. To get into the first quadrant is a single pi over 6. To get to the second quadrant, that's 1, 2, 3, 4, 5 pi over 6. To get to the third quadrant is 1, 2, 3, 4, 5, 6, 7 pi over 6. And to get into the fourth quadrant is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6. Now, I hope that you recognize these numbers and you're starting to kind of get used to them popping up, because, man, they show up frequently, okay? We're seeing these answers like over and over and over again.
2 times the cosine squared of theta equals 1 minus the cosine of theta, where theta is between negative pi and 2 pi.
All right. Now, let's take a quick look at the domain of this function before we pop in. This is negative pi to 2 pi, so that's a negative half rotation and then a positive full rotation. Okay. Now I'm going to take a look at the trigonometry here, and I can see cosine showing up in a couple places here, one where it's squared, one where it isn't. So, like I did in a previous question, I'm going to just replace that with an x. Mostly because I don't know what cosine of theta is, so I might as well just be working with an x. It's quadratic, so I'm going to bring both those terms to the other side here. So this will be 2x squared plus x minus 1 is equal to 0. Now I'm going to factor that. And the nice thing is I got a 1 at the far end here, so that means those two have to be 1. And then I've got a 2x squared, which means one of these things has to be 2x, and the other one's just got to be x. And the question is, how do I get that positive one to show up? Well, I'll get a positive one to show up if, when I multiply those together, I get positive 2. When I multiply those together, I get negative 1. So there we go. I factor this now. Now, either x is equal to positive 1/2 or x is equal to negative 1. So I've solved the algebra level of this. Now what I got to do is move to the trig here. So now the cosine of theta is equal to 1/2, or the cosine of theta is equal to negative 1. Let's start here. Cosine is positive, okay, in 2 quadrants. The 2 quadrants here are going to be 1 and 4. Now that tells me I'm going to get 3 solutions out of this first factor here. Now, what reference angle takes us, and I'm going to kind of skip over the inverse cosine. I hope you're getting used to this. I'd like to kind of push this through a little quicker. What reference angle connects cosine to 1/2 in radians? Well, the answer is pi over 3. Okay? Now, remember what pi over 3 says. Pi over 3 tells me that I'm chopping the top half and the bottom half of the circle into thirds. I want first quadrant angles and fourth quadrant angles here, but I've got two different domains that I'm working on. First of all, I've got that negative domain that puts me this way. Now, in the fourth quadrant on a negative rotation, the first angle I get to here is this one, and that's just going to be negative pi over 3. When I move to my positive rotation, okay, the first angle I bump into is in the first quadrant, so that's just going to be positive pi over 3. And then the next one is all the way around to here in the fourth quadrant. That's 1, 2, 3, 4, 5 pi over 3. So those are the three angles that I get from this particular factor. Then I move on and take a look at this one. And I know we've mentioned this before, as soon as you see sine or cosine going to -1, 0, or 1, really what I want to do is have a quick look at my unit circle. 1, 0, 0, 1, -1, 0, 0, -1. And now what I'm interested in here is, remember that cosine is associated with the x coordinate, so what I'm interested in is where the x value, okay, what point here has an x value of -1. And in this case, the only answer that fits that is when I'm on the negative x-axis. Now, in my domain, let's just take a quick look at this. In my domain, I'm going to hit this actually a couple of times. First of all, I'm going to come back and hit it on my negative rotation. So I'm going to hit this at negative pi. Okay, because my negative rotation takes me right back to negative pi and includes it. And then on the positive rotation, I'm going to hit it when I go past it. I'm going to hit this at positive pi. So I'm getting two solutions out of this particular factor as well. And so here are my 5 different solutions to this equation.
The cosecant squared of theta minus 3 times the cosecant of theta minus 28 equals 0, where theta is between 0 and 180 degrees.
Okay, all right. In this equation, we're looking at a domain between 0 and 180, inclusive, but still just the top half of the circle. That's it. Now we're going to move over here, and here's another one that's quadratic and cosecant. So I'm going to replace the cosecant with an x. So we get x squared minus 3x minus 28. So I'll deal with the algebra, then I'll get to the trig later here. So I'm going to factor this quadratic, and so I need factors of negative 28 that combine to get negative 3, and the answer should be, hopefully fairly clear to you, the answer here should be negative 7 and 4. Okay, so now this means that x is going to equal positive 7, or x is going to equal negative 4. Once I'm here, I will replace those with the cosecant of theta. So either the cosecant of theta, either the cosecant of theta is equal to 7, or the cosecant of theta is equal to negative 4. Now, at this point here, I don't want to work with cosecant, so I'm going to reciprocate both sides. And wow, I can't believe I just wrote that. But this is going to become the sine of theta is 1/7, because I have to reciprocate both sides. Sine of theta is equal to negative 1/4, because I have to reciprocate both sides. Now, I'll solve one of these at a time here. However, when I look at these guys here, notice that I don't recognize either of these ratios from the unit circle, special triangles, or anything. But that's okay. That just means I got to use my calculator to solve this. So first of all, I see that sine is positive. So what this means is I'm going to get an answer in the first quadrant and in the second quadrant. Okay, so I already know I'm going to get a first quadrant angle and a second quadrant angle. Now, again, without going through and writing that all out here, I'm just going to find this. So I make sure I'm in degree mode, and then second sine, 1 divided by 7. Ooh, okay, and I'm getting just 8 degrees here. Okay, because I'm going to round that to the nearest degree. So just 8 degrees, which means in the first quadrant I'm going to get 8 degrees, okay, because I'm just going to go directly up to the terminal arm. But over here I'm going to go 180, and I'm going to lose that 8 degrees. So 180 minus 8 is going to be 172, roughly. Okay, so good. So those are the two answers I'm going to get from that first, that first factor here. Now I come over here, and I look at this. Sine is negative in quadrants 3 and 4. But my domain doesn't extend into quadrants 3 and 4. So this question is done right here. There's going to be no solutions coming from this particular factor here. My only two answers here will be the 8 and the 172.
2 times the cosine of theta squared plus 7 times the cosine of theta plus 3 equals 0, where theta is between 0 and 2 pi.
So for this next question, again, let's take a quick look at our domain here. And then again, nothing new here, 0 to 2 pi, so complete rotation, and again, we're including the endpoints. Once again, this is quadratic in cosine, and again, I don't want to work with that right now, so I'll replace the cosine with x. Okay, and I'll solve the quadratic first, and hopefully this can be solved nicely by factoring, but we'll see. So we got to try to get a 7 in the middle there, and actually I think it looks pretty clear that if we do this, okay, 2x, x, 2x squared, we get 6, and 1 is 7, and then 1 and 3 is the 3 there. So that's what I want here. So x is either going to be -1/2 or x is going to be -3. All right, now once I'm at this point right here, I can put my cosine back in, and I get the cosine of theta is equal to -1/2, or the cosine of theta is equal to -3. Let's take a look at this first one. Cosine is negative. Okay, let's come up here. Cosine is negative in quadrants 2 and 3. Good. Now we're going to come down here. Remember, I'm looking for a second quadrant angle and a third quadrant angle. I will take the inverse cosine of 1/2, not -1/2, 1/2, because remember, I'm looking for the size of the angle, not the position here. Now let's just think here. What reference angle connects 1/2 to the cosine? And in this case, remember we're in radians here, so that's going to be pi over 3. Okay, so what pi over 3 does, that reference angle, is it chops the top half of the circle up into thirds. Okay, I'm looking for an angle in the second quadrant. Well, that's going to be this terminal arm right here, so that's going to be 2 pi over 3s to get into the second quadrant. To get into the third quadrant, that's this terminal arm right here, that's going to be 1, 2, 3, 4 pi over 3s. So those are the two solutions that I'm looking for that come from this first factor. Now we move over to cosine of theta is equal to -3. Cosine is negative, again in quadrants 2 and 3. However, in this case right here, notice that the ratio that we're getting here is actually outside the range of cosine. Cosine values should only ever fluctuate from -1 to 1. We've seen that a few times already. Cosine can never go to -3, so there's no solution here. And you got to love it when that happens in a problem, because that cuts down your workload if you recognize it. Now, if you don't recognize that, you could end up doing a whole bunch more work. You're going to get a wrong answer there. So you want to pay attention to when those ratios there are less than -1 or greater than +1, because then those are, you can immediately say, no solution. So in this particular question, the only two answers we're looking for are 2 pi over 3 and 4 pi over 3.
2 sine theta cos theta is equal to the 3 times the sine of theta, where theta is between -pi and 0.
Now in this case, look at the interval that I'm finding my solutions on. Okay, it's kind of an interesting. This is -pi up to 0, but not including 0. I'm going to include the -pi, but I'm not going to include the 0. That's kind of interesting. We haven't seen a lot of those yet where we're including one endpoint but not the other. Anyway, doesn't matter. Let's keep moving here. Let's take a quick look at what I got here. And oh boy, I've got two different trig functions here. Now, having two different trig functions inside an equation like this is not useful typically unless I can separate them apart by factoring. Do not, I repeat, do not cancel the two signs on both sides. If you do that, you're going to lose part of the solutions to this problem. Okay, the way you want to think about it here is I've got a sine theta. Bear in mind, the unknown here is the theta. There's the sine of theta, the cosine of theta, and they're multiplied together. In essence, this is quadratic, okay? I mean, because I'm multiplying those together. Now, I understand it's not exactly quadratic, but hopefully you get my sense here. What you need to do to solve this is to bring that 3 sine theta over to the other side of the equation here. Now, instead of canceling those out by dividing by sine, what I'm going to do is I'm going to factor that out. And then I'm left with 2 cosine of theta minus 3 equals 0. Now, that is a much better solution, okay? Because in this case here, or sorry, a much better form of the equation here, because the sine and the cosine have been factored apart. They're in two different factors here in this equation. So now, my solution is either that the sine of theta is equal to 0, or that the cosine of theta is equal to 3 over 2. Now, let's take a look right here. Notice sine is equaling to 0. Now, whenever sine or cosine go from -1, 0, or 1, I understand that to be a unit circle problem here. So let's take a look. I keep doing that. Let's take a look at our points as we go around the unit circle. And remember, the issue here is that we want to associate sine with the y-coordinate. So where does sine go to 0 as you go around the unit circle? The answer is it's on the it's on the x-axis. On the x-axis, the y-coordinates are 0. Now, that means in considering our domain here, I would normally include 0, but my domain doesn't include 0, so I can't. So the only thing that I can do here is include that negative pi. So my answer here right now is that theta is equal to negative pi. Okay? Now, I come up to my second factor here. Cosine is positive. Well, okay, cosine is positive in quadrants 1 and 4. However, notice that the ratio that I'm getting here, okay, cosine of theta is equal to 3/2. That's larger than 1. Well, that's not possible. I can't do it. Now, it's close. It's closer than it was in like the previous question. But in this case here, it's still greater than 1. So there's no solution. So the only answer to this one right now is that theta is equal to negative pi.
Cotangent squared of theta plus the cotangent of theta equals 0, where theta is between negative pi and pi.
Okay, we're just going to keep on keeping on here. Almost done with these examples. Take a look at this one right here. I've mentioned it before. I like this domain, a negative half rotation and a positive half rotation. Now I come over here. This is quadratic in cotangent, and again, I'm just going to deal with the algebra here first. So I'm going to replace cotangent theta with x, and really all I can do at this point here is factor out the common x. And so now, with the product equaling 0, this means either x is equal to 0 or x is equal to -1, which allows me to state that the cotangent is equal to 0 or the cotangent of theta is equal to -1. Okay, now this question looks remarkably similar to one that we've done earlier, but there is an interesting little twist here. Now, I don't want to work with cotangent. I'm assuming most of you probably are in the same way, kind of same frame of mind here. So I'm going to reciprocate these guys here. But when I reciprocate 0, okay, I get 1 over 0. I'm going to get undefined. Okay, 1 over 0 here. Over here, when I reciprocate this, well, the reciprocal of -1 is just going to be -1. That's not going to do much. But this is an interesting one. And let's talk about that. Because remember, when tangent goes from 0 or, is either 0 or undefined, we're talking about the angle being on the axes here. So let's take a quick look again at the unit circle. So 1, 0, 0, 1, -1, 0, 0, -1. Remember, tangent is the y-coordinate over the x-coordinate. So I got to think, for what points will that be undefined? And that's going to be undefined when the y-coordinate is 1 and the x-coordinate is 0. Sorry about that. Where the y-coordinate is 1 and the x-coordinate is 0. So that occurs on the y-axis here. So looking at my domain here, to get to the y-axis, it's this quick little rotation here or a little rotation here. So the only two angles that kind of fit in the domain that I've been given will be negative pi over 2 or positive pi over 2. Okay? Along the negative rotation and then along the positive rotation. Now I move to this one right here. Tangent is negative. Okay, well, tangent is negative in quadrants 2 and 4. Okay, so I know I'm going to get a second quadrant angle, and I'm going to get a fourth quadrant angle. Sorry, I'm going to get a fourth quadrant angle. My reference angle in this case, I got to think, well, what reference angle connects tangent to the value 1? And in this case, it's pi over 4. What that means is we are chopping the top half of the circle into quarters as well as the bottom half. To be in the second quadrant, that is this terminal arm right here, that's 1, 2, 3, 3 pi over 4. And to get into the fourth quadrant, now remember, I got to do this along the negative rotation, so that's just going to be a negative pi over 4 into the fourth quadrant. And so here are my solutions. Negative pi over 2, pi over 2, 3 pi over 4, negative pi over 4.
3 secant theta is equal to 2 plus the secant squared of theta, where theta is between negative 360 degrees and 0 degrees.
Okay, here we go. Let's take a quick look at our domain before we jump into the equation here. Negative 360 to 0 puts us at a negative full rotation. So that's what we're looking at. Again, I've got this thing quadratic and secant, so I'm just going to eliminate the secant just by replacing it with an x squared. The result is quadratic, so I'm going to bring everything over to the right-hand side. And now I will factor that. I got to think here, what are my factors of 2 that are going to give me negative 3 here? Well, what I'm going to do here is make these both negative. So if I multiply this out here, I would get negative 1x, negative 2x. There's my negative 3. So x is going to either equal 1 or x is going to equal positive 2. At this point, I can replace x with my secant. And now I look at these guys and I think, I don't really want to work with secant. I would rather work with cos. So I'm going to reciprocate both of these, both sides. But the reciprocal of 1 is just 1, so that's easy. And then the reciprocal of 2 will be 1/2. Okay, now, here are equations, little trig equations here that I've solved before here. We got cosine going to 1. Okay, now, whenever cosine goes from negative 1 to 0 to 1, that's typically going to be on one of the axes here. So it makes sense to take a look at this in terms of the unit circle. Now, when we're talking cosine, we are talking about the x-coordinate. I need you to, again, to relate cos to the x-coordinate. So where does cos go to 1? Where does the x go to 1? Well, only here, along the positive x-axis here. But watch this. That would be just along here. So that would be 0, but I don't include 0. Or the negative 360, but I don't include the negative 360. So it turns out there's no solution here. Not from this particular factor. Okay? Because the solutions that exist don't exist in the domain that I've been given. So I move on. Here, cosine is positive. Okay, well, cosine is positive in quadrants 1 and 4. So I am going to get a first quadrant angle and a fourth quadrant angle. Now I have to look at my reference angle. What reference angle do I connect cosine to 1/2? And the answer is 60 degrees. But I got to remember that I'm doing this in a negative rotation here. So to get to the terminal arm in the first quadrant that I rotate into, which is the fourth quadrant, that's going to be negative 60. So in the fourth quadrant, this is negative 60 degrees. Then to get to this one out here, I have to go all the way around here. I would overshoot because I have to compare this to the x-axis. So negative 360 and then go back here. This is a positive rotation plus 60. And that is going to get me negative 300 degrees. So those are the only two solutions that I'm going to get from this equation.